Section 2.3, Example 3. Okay, in Example 2, we worked on finding the zeros of a polynomial, but we also said those zeros were the same thing as the x-intercepts. So when you hear me say a zero, think x-intercepts. So if we've got a zero of a polynomial and it's of an even multiplicity, okay, what's a multiplicity? Well, that's just how many times that zero is used as a factor. So if it's used as a factor twice, it's even multiplicity. If it's used as a factor 3 times, it's an odd multiplicity, okay? So if it's an even multiplicity, the graph just touches the x-axis and then turns around at that zero or at that x-intercept. If a zero is an odd multiplicity, then the graph just crosses the x-axis at r. It doesn't turn around. Whether the multiplicity of a zero is even or odd, graphs usually flatten out near zeros with a multiplicity greater than 1. Okay, so in Example 3, we're going to find zeros, which we did in Example 2, but we're also going to talk about their multiplicities and what they mean. So we've got this polynomial where we need to find the zeros of f of x equals -4 times the quantity x plus 1/2 squared times x minus 5 cubed. We also need to give the multiplicity of the zeros and state whether the graph crosses the x-axis or just touches it and turns around. Okay, so continuing on, first we're going to find the zeros of the function by setting f of x equal to 0. So here we have -4 times the quantity x plus 1/2 squared times the quantity x minus 5 cubed. Now, it's really already factored, thank goodness. So now we just take this first part, x plus 1/2, that quantity squared equals 0. What to undo a square? You're going to take the square root, and what you do to one side, you do on the other. So you'll end up with x plus 1/2 equals 0. Well, when you subtract 1/2 from both sides, you end up with x equals -1/2. Now, over on this side, x minus 5 to the third power equals 0. Well, to undo a cube, you take the cube root, and so you'll end up with x minus 5 equals, well, the cube root of 0 is still 0. Add 5 to both sides, and that's how we get x equals 5. So x equals -1/2 is one of the zeros. X equals 5 is the other zero. But now let's talk about their multiplicities. The x equals -1/2, that was raised to the x plus 1/2 was raised to the second power, right? So that's got a multiplicity of 2. X minus 5 came from right here, x minus 5 to the third power. That has a multiplicity of 3. You're really just looking at the exponents. Okay, for the x equals -1/2, for that zero, remember we just said it had a multiplicity of 2. 2 is an even number, and in your notes you can pause and check, but if it has an even multiplicity, it means the graph is just going to touch the x-axis at x equals -1/2, and then it'll go back up. Now for our other root, x equals 5, that had a multiplicity of 3. Once again, there's where that came from. And so that's got an odd multiplicity. And so when a multiplicity is odd, it's going to cross the x-axis at that 0. So it should cross at x equals 5.